So something that you're going to see on your test, most likely, especially if you have an evil professor like me, is a problem like this. What are the solutions to this? Right away, we got to get, everything has to be in the same terms, right? Hopefully you're starting to get used to the idea that sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x divided by 2. This is one of those things you just need to know. I'm going to have to do a substitution then. That means that sine squared is this squared, and doesn't matter if it's plus or minus, the square kills it. Incidentally, that can come back to bite us later. Keep that in mind. May have killed minus sign. And we'll talk more about this later, but keeping in mind what is done. So 4 times this is going to be red. Try some blue. I need better colored markers. I'm bored with these. So this is literally 4 times this square root squared goes away. This is 1 minus cosine x over 2 plus cosine squared x is equal to 2. 2 divided into the 4. This goes like this. There's only 2. Now we distribute it through, and we have 2 minus 2 cosine x plus cosine x squared is equal to 2. This is what I'm going to do. I'm going to subtract 2 from both sides, and this goes away. And I'm going to turn it around, because I like my squares on the left. I'm sorry. We get peculiar in time. It will happen to you. This is cosine squared x minus 2 cosine x is equal to 0. This has the form of some variable, so let's let y equal cosine x. Then this is y, so this becomes y squared minus 2y equals 0. You factor this. This is just y times y minus 2 is equal to 0. Right? So let's do this. I'm going to factor out a cosine x. So I have this. I have cosine x times cosine x minus 2 is equal to 0. So this means that cosine x is equal to 0, or cosine x minus 2 is equal to 0, which implies that cosine x is equal to 2. What's wrong with this right away? I'm already suspicious that I may have screwed up. Cosine x, the biggest cosine x ever gets to is 1. This has no solutions. So right away, number 1, I better figure out if I screwed this up. Or it may just be that that's part of a term. I mean, it says if you have this, a times b equals 0, either a equals 0 or b equals 0 or both. So maybe this one just doesn't equal 0. Okay. But because I just saw something that I wasn't anticipating, I am going to relook at this immediately. First, go back to the book. Did I even write the problem down right? Yes, it appears that I did. Secondly, go back to the transformation. Is in fact sine x over 2 square root plus or minus 1 minus cosine x over 2? Yeah, it is, unless the mad cow kicked in really hard today. Square takes the square root out. I kept my minus sign. I didn't blow that. There was a 4 down here, or there was a 4 up here, 2 down here. The 2 goes through. 2 hits here and here. The 2's cancel. I believe that. Okay, so far so good. I believe it. So this is no viable solutions. So this must never be 0, and we don't have to worry about it, which is kind of nice, because all I have to think about is cosine x is equal to 0. Well, when is cosine x equal to 0? And we need to be careful here. And now we're going to do a picture. Cosine x is equal to 0 at pi over 2. Cosine of pi over 2 is equal to 0. But is it equal to 0 anywhere else? And yes, it is, because cosine is an even function. Cosine of negative pi over 2 is equal to 0 as well. So once again, this cosine equals 0, cosine x equals 0, has two distinct branches. Pi over 2 plus 2k pi, where k is an integer, or negative pi over 2 plus 2k pi, where k is an integer. Number one, are these in fact different roots of a solutions? And yeah, they are, but I'll show you in a minute why they are. It's really careful. You really need to be careful. And the truth is that if you just want to get a C in a math class or a physics class, it's going to cost you a lot of work. But these little details, you can probably, choke your way through and fake it halfway. However, if you want to get an A, and I hope there's not a single student who's listening to me who thinks they want anything less than an A, you need to have these details in mind. And now let's see why. Remember we talked about this in the last tape, y sine. So remember we showed y sine of x is equal to 1 only had one branch of solutions. And the reason I'm calling these branches is because adding the 2k pi goes on and on and on. We said that x is equal to pi over 2 plus 2k pi for k as an integer. This has only one single branch. These answers go off in a certain direction, I suppose you can think about it. And the reason was because sine has period 2. And the picture of sine showed that 1 and negative 1 are only going to happen once in every 2 pi. However, just like sine, now let's do cosine. So cosine, I'll do this, pi over 2, pi, 3 pi over 2, and 2 pi. Here is 1, here is negative 1. Let's take a look at cosine once again. This would be good to know. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1, 0, and this. And let's put some more back here. Negative pi over 2, negative pi, negative, shoot, I'm running out of room here. So this is negative 3 pi over 2, and finally, negative 2 pi. Let's put this back in. This is going to be negative. This is 0. This is positive. So here's my best drawing of this. Okay. I'm really only going to think about this interval right now, though. Remember we said pi has, or sine has period 2 pi. So does cosine. Incidentally, this is cosine. Cosine x. So where is cosine of x is 0 has what kind of x equals 0? When is it going to be 0? Well, it's 0 here on the way going down, but it's also here, 0 here on the way going up. There's two different branches of the solution, and incidentally, are these the same? Negative pi over 2. If k is 1, you add it, and you get 2 pi to negative pi over 2 is 3 over 2 pi. You could have wrote this as 3 pi over 2 plus 2k pi. I'm totally okay with negative pi over 2. A lot of people, this is technically correct. The whole point is, though, what would have just one solution, one branch, and that would be, when is cosine x equal to 1? Well, it's equal to 1 at x is equal to 0 plus 2k pi, for the same reason that sine of x is equal to 1 just once. So these are subtle details. My producer tells me we're running out of time. The solution to this then were these two distinct branches that you can see on the unit circle. We know that cosine of pi over 2 is 0. And clearly from the picture itself, cosine of negative pi over 2 is 0. Anytime we wrap around 2 pi's or subtract them, we're still going to have solutions. We are out of time. We'll be back next time. See you later.